of radicals and functions. So quick review of simplifying 50. What is the best way to simplify 50? 50 is what times what?
25.
Okay, there are a lot of choices here, but the best one would be 25 times 2 because what's the square root of 25?
5.
All right, so 5 root 2 is how we simplify that. Okay, and now we've got the product of square roots rule. So this is new. Anytime you multiply two radicals together, their insides multiply together. So if I've got, and their outsides multiply together. So let's say I have 5 root 12 times 4 root 3. So whenever we have two radicals and we're multiplying together, we multiply the outside numbers together. And so 5 times 4 gives me 20, and that stays on the outside. And then we multiply the inside numbers together. So 12 times 3 is 36. Okay, and then we see if we can simplify it any further. So outsides together, insides together, then simplify. What's the square root of 36? 6. Do we need to put this? I saw this on your guys' test. Some people did that. Should we leave a 1 inside that square root? No. What's the square root of 1? It is 1, and anything times 1 is itself. So you guys don't leave anything in the house if it's a perfect radical, a perfect square root, okay? So now I have 20 times 6 gives me 120, and we're done, okay? All right, let's try another one. 4 root 3 times 3 root 2. So Lucas, which numbers multiply together first?
4 and 3.
Yep. The outside numbers first. So 4 times 3 gives me 12. Okay, and Andrew, which ones multiply together next?
The ones on the inside.
The ones on the insides. 3 times 2 is 6. Okay, Monica, does 6 simplify at all? No, because 3 times 2 is 6. There's no perfect square numbers inside that radical, so it's done. 12 root 6 would be our answer. What if we're distributing? So write this one down. 3 root 2, parentheses, 4 root 3 plus 5 root 6. So we're just going to distribute, right? So I'm going to multiply this to this with a plus sign in the middle, and then this to this. So start with our first times our first. When we multiply those together, Caleb, what numbers multiply together first? Good, the outside numbers, which gives me 12. And Jordan, which numbers multiply together next? Good, and we get root 6 plus. Now I'm going to distribute to the second part. So Jackie, which numbers multiply together first? Good, the outside numbers first. That's 15. And Sophie, what do I multiply together next? Yeah, the inside the house numbers. 6 times 2 is 12. Dylan, do you think this simplifies any further? Yes. You're right. Micaiah, how could I simplify this?
Well, 12 is 4 times 3, and 4 is square root of 4 is 6.
Exactly. Okay. So the square root of 4 is 2. So simplify 12, because 12 is 4 times 3, and the square root of 4 is 2. So 12 root 6 just stays the same, right? And then I'm going to multiply this number here. We get 30. What's left inside the house? 3. All right, so go ahead and write that one down. 4 root 2, parentheses, 3 root 2 plus 5. So that second number there inside the parentheses does not have a radical on it. So let's see what happens when we multiply those. So 4 root 2 times 3 root 2. Isaac, what should I multiply together first?
The 4 and the 3.
The 4 and the 3. So my outside numbers give me 12. And Sophia, what should I multiply next? The 2 and the 2, which gives me 4. Okay. Now I have a plus sign because we're distributing. Okay, Evie, what do you think? Which numbers do you think multiply together here? Yeah, only the 4 and the 5, because the 5 is really an outside number. So we end up getting 20, and we still have root 2. Okay, so when I multiply those together, the outsides multiply, but I still get root 2. Ben, do you think this simplifies further? Yeah. What's the square root of 4? It's 2. Okay, it goes away when it's a perfect radical. No more square root, right? Square root of 4 is 2, and those multiply together, so I have 24 plus 20 root 2. All right, now let's talk about functions. Which of the following diagrams depict functions? All right, first of all, everything is a relation, or almost everything. But we really want to know, is it a function? So go ahead and draw these pictures here. Whatever's listed first is our input, and whatever is listed second is our output. Okay. So we plug in A and we get 5. And then we plug in 6 and we get 11. And then we plug in 7 and we get 11. All right, and then over here we've got our input, X and Y, and our output, X gives me P, and Y gives me A and 7. For a relation to be a function, each input can only have one output. Each input can only have one output. So when you look at these two, one of these is a function, you guys, and one of these is not a function. Anyone know, based on that definition, which one is not a function? Nico. Because? Exactly. All right, this is the big no-no. I plugged in Y. How do I plug in one thing and get two things out, right? Two different things out. So this one is not a function. Nope. Can't plug one thing in, get two things out. This one is a function. It's okay to do that. Okay? You just can't have one thing go to two things. Okay? That's not a function. Both are relations. Does the diagram depict a function or a relation? So this one's tricky, but go ahead and draw that. We've got 6 going to 4, 7 going to 11, and then we've got this rando 5 there at the bottom. Okay? If you have a random number attached to nothing, this is actually neither. Okay? It's not a function, and it's not a relation. Okay? So if you have some number not connected, doesn't have any friends, that would be neither. All right? Neither. So those are 3 things that can happen. It's a function, it's not a function, or neither. What's the domain and range? All right. So this one's pretty easy, you guys. Domain is the set of input numbers. So I just list them. So Evan, what should I list for my domain? A, 6, and 7. Exactly. And then we've got the range. Ella, what should I list for my range? Nice. 5 and 11, just my outputs. Okay, and this didn't actually ask, but let's go ahead and ask ourselves, is this a function? Yes or no? Nate, what do you think? Yes. You are correct. Okay, the only time it doesn't work is when one number goes to two numbers. This one's good to go. It is a function. All right, which of the following sets of ordered pairs represents a function? So you're also going to see them listed as ordered pairs. So go ahead and write those ordered pairs down. 2, 1, 1, 2, and 2, 2. I'm going to tell you guys right now, this is not a function. what I want you to tell me is why it's not a function. Alex, what do you think? Not sure. What do you think, Nico?
2 has 2 outputs.
Because 2 has 2 outputs, and they're different. Okay? So, what happens here? I plugged in 2, I got 1. I plugged in 2, and I got 2. Problem, right? So you can't plug one thing in and get 2 different things out. So, is this a function? Nope. Okay? So circle the points that make it a no so you guys know why. Okay? We plugged in a 2, and we got a 1 and a 2. Impossible. All right, right here. So I've got 1, 2, 1, 2, and 2, 2. Aaron, what do you think? Is it a function? Yes, I agree with you. Why is this one okay, you guys? Bethany? Exactly. That's okay. I plugged in 1 and I got 2. I plugged in 1 and I got 2. That's the same thing. So we're good to go. Yes, it's a function. Okay? How about this one? I've got the point 1, 2. I've got the point 1, 3. And I've got the point 1, 4. Julia, what do you think? You are correct. All 3 of these make it not true because I plugged in 1 and I got 3 different things out. So it's not a function. How about this one? 2, 1, 3, 1, 4, 1. Raise your hand if you think it is a function. If you think yes. Raise your hand if you think it is not a function. You guys are all correct. Good. This is yes, it is a function. It's totally okay. We plugged 3 different things in, and we got the same thing out. That's okay. You just can't plug one same thing in and get 2 different things out. Okay? All right, let's try it on the whiteboards. Oh, sorry.